So the question essentially asks you to imagine a chessboard as a graph, which is neat because it's not something that you would naturally think of as a graph, at least unprompted. So yeah, it says that every square represents a vertex, and we have an edge between two squares whenever there are knights move away. So for example, here there would be an edge from the center square to here, and to all of the other squares marked with an X. And so now we want a two coloring of the graph. And so yeah, recall the definition of the two coloring, which is we want to be able to color vertices so that if two vertices are connected by an edge, they have different colors. Yeah. So translating that, we want if two vertices are knights move away, different colors. And yeah. So if you look at a diagram for a moment, you'll notice something interesting, which is that the knight here starts on a black square, and all of its options for places to move are white squares. And if you imagine the knight starting on a white square, for example, if it moves here, you can see that all of its options for places to go are black squares. And so we can notice that if u and v, if the edge u comma v exists, so if u and v are connected by a knight's move, then they have diff colors on the board. One must be black and one must be white. Yeah. So we're done. Because the existing coloring of the chessboard works as a coloring for this particular demand. Yeah, if two squares are connected, different colors. And in this case, connected, we mean they're directly connected to each other by a knight's move, not like one is eventually reachable from the other. So yeah, that's the question. It's surprisingly tricky. Or well, not really, I lied. Yeah. And so now the second part asks you to show that the black knight can never be captured, even if it's actively trying to be captured. And so going back to our image here, we know that, importantly, diagonally opposite corners is where they start. So for example, you could have the white knight here and the black knight here, or you could have the white knight here and the black knight here. And in both cases, we know that they both start on the same square, or like the same color square, I should clarify. And so at the beginning of the first turn, we have something like white and black. And after the first turn is played, the white knight has to go to a black square. It could be this one, could be this one, could be something else, but it has to go to a black square, and the black knight also has to go to a black square. And so at this point, the black knight is on a black square, and the only spaces threatened by the white knight are the white squares. So that, and so on. And so obviously, it'll be impossible for the white knight to ever be threatening the black knight, and so it's impossible for the white knight to ever capture the black knight. Yeah, so the formal way you would write this up is something like, after a turn, black and white knights so white knight can't move to the square the black knight is on. So cannot ever capture. And like this is just a fact about the structure of the chessboard graph that we imagined in this question. It doesn't matter what strategies they're both playing, or whether one's an excellent player or whether one's a terrible player. It is just an inherent fact that falls out of the structure of the graph.